All right, today we're going to talk about something really powerful, something that's basically the engine behind science, business, you name it. We're talking about hypothesis testing.
I mean, you hear this stuff all the time, right? This new drug is a game changer, or our new ad campaign totally worked. But how do you really know? How do you get past just a gut feeling and actually prove it with cold, hard data?
Well, it turns out there's a formal process for exactly that. It's called hypothesis testing. And honestly, it's the foundation for making smart, data-driven decisions.
And here's the best way to wrap your head around it. Just think of it like a courtroom trial, but for an idea. Seriously, we're going to put a claim on the stand, look at the evidence, and decide if it holds up. This whole trial analogy is going to be our guide through this.
All right, let's get into it. What exactly is this trial all about?
So here's the textbook definition. It's basically a formal way to take a small slice of data, a sample, and use that to make a really smart guess about a huge group, the whole population. It's how we can make these massive, confident claims with just a little bit of information. It's pretty cool.
Okay, so every good trial needs two opposing sides, right? The prosecution and the defense. In our statistical courtroom, we call these the hypotheses.
First up is the null hypothesis. You'll see it written as H0. Just think of this as the default, the status quo. It's our innocent until proven guilty. We have to assume this is true unless we find overwhelming evidence against it. And then, on the other side, you've got the alternative hypothesis. This is the challenger, the new idea we're trying to prove. It's the charge we're bringing against that default.
Okay, let's make this super clear with an example. Say a school claims its students have an average score of 60. The null hypothesis, the default, is simply that the average score is 60. That's the school's claim. But let's say we think the students are actually doing better. Our challenge, the alternative hypothesis, would be that the average score is actually greater than 60. So we've got our two opposing sides. Now what? Well, just like in a real courtroom, you can't just convict someone on a whim. You need a standard, right? We have to set the burden of proof.
In the stats world, this is called the significance level, or you'll hear it called alpha. And what it really is, it's the amount of risk we're willing to take of making a huge mistake. Specifically, the mistake of convicting an innocent person, or in our case, rejecting the default claim when it was actually true all along. This little number sets the entire bar for how strong our evidence has to be.
So what's the magic number? Well, you'll see this everywhere. It's almost always 5%. And you might wonder, why 5%? It's really a sweet spot. It's tough enough that we don't just jump to conclusions based on flimsy evidence, but it's not so tough that we can never prove anything new. What it means is we're willing to accept a 5% or a 1 in 20 chance of getting it wrong and making that wrongful conviction. It's the perfect balance. Okay, so the court is now in session. We've got the two sides. We've set the burden of proof. Now it's time for the main event, looking at the evidence. And to do that, we need a way to measure it, a kind of universal yardstick.
And the logic here is actually really simple. First, we just measure the distance. How far off is the data we collected from the original claim? But just that number doesn't mean much on its own, right? We need context. So the second step is to standardize it. We turn that distance into a universal measurement that everyone can understand. We call this the z-score. And the z-score formula, it does exactly what we just said. You take the difference between what your sample found and what the original claim was. And then you divide it by something called the standard error. Don't let that term scare you. It's just a way of factoring in how much things naturally bounce around in your data. It puts everything in perspective. This final number, the z-score, that is our key piece of evidence. So for our school example, let's just say we crunch the numbers and we get a z-score of 2.0. Okay, this is it, the moment of truth. We have our evidence, that z-score of 2.0, and we have our burden of proof, that 5% risk level. The big question is our evidence strong enough? Is it enough to overturn the school's claim? So how do we decide? We look up a benchmark number that goes with our 5% risk level. Now, because we're only testing if the score is greater than 60, not just different, it's called a one-tail test. And the table tells us the benchmark we have to beat, our line in the sand, is 1.645. If our evidence is bigger than that, we've got something.
All right, here we go, the final showdown.
Our evidence, that z-score of 2.0, goes head-to-head with the benchmark 1.645. And look at that. 2 is bigger than 1.645.
Our evidence is stronger. It crossed the line. That means we met the burden of proof. We can officially, confidently reject the null hypothesis, the school's original claim overturned.
So we've made the statistical call. But the job's not done. A trial isn't over until the verdict is read so that everyone understands what it means. We have to translate this back into plain English.
You see, you never just say, we reject the null hypothesis. That's not helpful. You have to state your conclusion clearly, using very specific wording, like this. There is sufficient statistical evidence to conclude that students score significantly above 60. The verdict is in. Our challenge was a success. But hold on. Just like any real-world justice system, this process isn't foolproof. It's all based on probability, not 100% certainty. And that means, sometimes, the system gets it wrong.
And there are two main ways it can mess up. A type 1 error is basically a wrongful conviction. This is when we reject the default claim, but it was actually true. The consequences can be huge. Imagine a company spending millions on a new product that doesn't actually work based on a bad test. Then there's the type 2 error. This is when a guilty party walks free. We fail to find enough evidence, so we stick with a default claim that's actually false. And this can be even more dangerous. A life-saving new medicine could get shelved because a test failed to show how effective it was. The whole point of the process is to carefully balance the risks of making either of these mistakes.
And that's it. That's the whole process of putting an idea on trial. From laying out the charges to setting the burden of proof, weighing the evidence, and finally delivering a verdict. It's an incredibly powerful framework. So now that you know how it works, I have a question for you. What piece of common knowledge, what claim that you hear all the time, what would you put on trial?